Okay. So good evening, everyone. I am very much happy to see quite number of participants today also. And I hope that yesterday's lecture was insightful and you could gain some knowledge about the latest drone technology in the remote sensing and the geospatial sciences. So yesterday we had basically covered the basics of drone technology. And today I will dive a little bit deeper and we'll go through the fundamentals of drone image processing. Okay. So coming to the contents, and today is the last day of our lecture series. So I will just brief you about the contents that I've completed yesterday. So in the day one, yesterday we went through the introduction of remote sensing first. That is, we answered to the questions. That is, what is remote sensing? And why are we choosing remote sensing? And why is there an advancement in the field of remote sensing? And then what are the processes or how does remote sensing happen? And what are the types of remote sensing? We talked about active remote sensing as well as passive remote sensing. And I winded up that session by saying about the use of both active and passive sensors in the remote sensing. So we covered our first topic, and then we came and I gave an overview of unmanned aerial vehicles, and that are basically known as drones. It is basically a remote controlled pilotless aircraft, and how and why we are switching to drone technologies nowadays. And we talked about what are the key characteristics of drones. That is the high spatial and temporal resolution, and then the use of battery and fuel, that like that it is more economical than compared to the satellite images. And then we talked about the evolution of drones, that we talked about how the throughout the history, that first we start with hot air balloons that we use for military purposes and surveillance, and now how we have replaced it using the drone technology, and how there is a more widened application of using drone technology across the world. Then also we talked how these drones are being replacing the traditional surveying methods, from electronic distance meters to the traditional total stations are also being replaced by drone technology for surveying purposes. Then we talked about components of drone, such as we talked about the battery, we talked about the propellers, we talked about the flight control units, actuators, etc., about the components of drone and why it is necessary to know about the different parts of the drone, because it will be easier for us to identify the problems. Then we talked about the aerodynamics of drone. Aerodynamics is nothing but how the air interacts with an object in motion, and what are the aerodynamic forces that act upon the drones. We went through that topic also, that is drag, lift, and thrust. Thrust is nothing but the force that is used while the drones take off. Then we talked about how the propellers move, the direction of movement when the flight takes off. That is, the front and rear will be in clockwise, and the left and right will be in anti-clockwise direction. Then we talked about the safety and legal consideration for flying drones in India. That we talked about the DGCA rules and guidelines that has been published in the 2021. And DGCA is acronym, and it is known as the Director General of Civil Aviation, and they have set certain rules before flying the drones. And we told about the penalties that we have to pay if we don't follow the rules and regulations that have been set up. Then we talked about the drone pilot licensing, what are the educational qualifications and who are eligible to acclaim it. And then we talked about the UAV, the resolution and data availability. That is the advantage of drones we had discussed. That is a spatial resolution, that is a temporal resolution, etc. And the economical viability of using drones, and how the application of drones have been widened across the globe. That is, before in time, we used drones or hot air balloons specifically for military purposes or surveillance purposes. Now it has expanded. Now we use it for precision agriculture. We use for oil, gas, and mining industries. We also use for recreational purposes such as marriages. Then we use even for disaster relief purposes. So these were the key applications and benefits of drones. And we ended up yesterday's session by talking about the challenges and limitations of UAV operations. That is the weather conditions that a drone might encounter, and then about the fuel capabilities. That is, if the payload increases, the weight of the payload increases, it can reduce the fuel efficiency of the drone, or the battery life of the drones will be affected. So this was the topics that were covered in day one. That is the basics of drone technology. Today we are going to talk about the fundamentals of capturing and processing drone imagery and data. Then we'll come about how to design a flight plan and how to compute number of flight lines that is necessary. Then we'll talk about computing the number of images. Then we'll talk about working for stitching drone captured images. Then we'll talk what are the data products that we'll acquire through the drone image processing. And I will mention few commercial and free and open softwares for drone image processing, which you guys can later look upon. Then I will talk about the applications of UAV for disaster management, and I will specifically talk about landslide studies where the drone technologies can be incorporated. And then I'll wind up today's session by giving you an insight about the basics of LiDAR remote sensing. Now let's move forward. So first comes the fundamentals of capturing and processing drone imagery and data. See, yesterday we talked about what is a drone, why are we using drones, what is UAV remote sensing. But what is the end product of all of this combined? That is, we will get an end result. That is the drone image that we acquire. It is very much important to know the quality of these images. Simply just flying the drone over an area, capturing the images and processing it does not give us the desired outputs. Always the quality of these images have to be checked. Okay. Yesterday, as I said that even the satellite remote sensing or the drone technologies, they basically uses visible and electromagnetic radiations to sense a target. And whenever we use, be it passive or active remote sensing, when a target absorbs, reflects, or emits an energy, especially when it reflects and when it goes back to the satellite or the drone sensors, it passes through the atmosphere, right, or the air. And the air is composed of lot of other components such as water vapors, small dust particles, and other gases. So whenever this EM electromagnetic radiation travels back from the target to the sensor, it can undergo lot of other reflections, and lot of noise can also be captured along with our data. So it is always necessary to understand the errors that can be attached along with the drone images that are captured. Okay. So we should understand the errors present. By understanding the errors that are present in the drone images, it will help us to process the image correctly. The major two errors that always we encounter, first is the radiometric error and second comes the geometric error. What is radiometric error? It affects how closely the brightness values captured by the sensor reflect the true reflectance from the surface being sensed. That is, suppose we are capturing an image from the drone. If it is a cloudy weather, we can get the shadow of the clouds. So what happens is that when we capture the drone image, the pixels or the reflectance of the objects might tend to be appear higher, that it might be little bit, objects might appear little darker. So it will modify or affect the original reflectance value of the object. And this happens mainly due to the difference in sun angles. It can be due to the topography, or it can be due to the atmospheric effect also. So this entire effect is known as radiometric error, and this can be rectified while we are processing the drone images. Next comes to the geometric error. It affects the proper positioning of images and pixels in the correct planimetric location, which is necessary if the data are to be associated with our spatial data. These geometric errors are basically caused by the motion, camera tilt, or terrain relief that a drone encounters. If a drone is going fast or if there is an error in the camera angles, we can encounter geometric error. Suppose we are capturing an image of an area through drone. It captures if it is captured in another position, that is in the perpendicular direction. But due to the geometric error that it faces, maybe due to the tilt or the motion or any terrain relief, suppose we are capturing a building, and when we process it, the building might be little bit stretched or it will be little tilted. This error happens due to this error is known as geometric errors. So by understanding these errors, we can use it while we are processing rectify these errors while we are processing the drone image processing while we are using the drone image processing softwares. Okay, so this is about the errors. Next comes georeferencing. Georeferencing is the process of aligning the images to a known coordinate. And I think most of you will be familiar with the term georeferencing. And the georeferencing can be classified into two types, that is direct georeferencing, and then comes the indirect georeferencing. In the direct georeferencing, the location information is also stored within the image file metadata. But while we are using this indirect georeferencing, with the users, we will always keep a reference data will be also collected when the survey is happening. When the drone survey is happening, we will collect GCP points, that is ground control points, to georeference the images. And sometimes when we georeference a satellite image, we mostly do it with either with GCPs or with topo sheets. So always make sure that the topo sheets that we use for georeferencing is at the latest version that is available. And whenever we go for georeferencing, we should always go for the permanent features that are available in the picture, such as a road, because road or some buildings it doesn't tend to change so often like the other features. So always go for the permanent features, or you can choose building corners while we are using for georeferencing, road edges, etc. So this is about the georeferencing. Next, other terminologies are orthophoto. Orthophotos are nothing but a geometrically corrected images so that the measurement can be made on the photograph as if it were a scaled map. Okay, orthophoto represent the Earth's surface as if we were viewing it directly from the perpendicular another direction of the camera. Okay, and then comes the spectral signature. What is spectral signature? Every object in the Earth has its own spectral signature. That is, every object absorbs, reflects, and emits different wavelength of energies. Okay, so suppose in this diagram, this green line here, it indicates the vegetation. Okay, it's a coniferous vegetation. It is a wavelength. So a tree or a leaf, it always reflects the green energy. That is why we perceive leaves in green color. And the red and blue are always absorbed. And there's a sudden peak here, that is, the vegetation always reflects NIR, that is near infrared energy, more. Okay, that is why when we capture satellite images and we visualize it in the false color composite, we tend to perceive vegetations in red color. Okay, so when the sunlight hits a target, the amount of reflections that comes to the sensor vary for different objects. So the amount of reflectance at each wavelength gives a curve, and this curve is known as spectral signature, and it can vary for different objects. Okay. Suppose the vegetation, if a healthy vegetation, as I said, it will always reflect the green and NIR more. Next comes to the focal length. The focal length is the distance from the center of the lens to the focal plane or imaging point where the light for the images is collected. And one important thing to note here is that if camera of the drone has longer focal length, the footprint of the image that is collected will be smaller compared to the camera with shorter focal length. Okay, that is, as we tend to fly higher, the spatial resolution also decreases. It is inversely proportional here. Next comes about image overlap. What is image overlap? It is the amount of overlap in ground coverage of two adjacent images. See, this is the drone. Okay, right now the drone is in this position here, and it is capturing an area of that I'm marking in the red rectangular box. So when the drone is in this position, it captures or covers an area of this much. When this drone moves forward to this position, it again captures another area. But you can see that there is a common area between both the images. This is known as overlap. Okay. Image overlap, it means that each drone photo covers part of the same area as the previous one. Actually, we are doing this intentional, it is actually intentional repetition of coverage so that we can make sure there is no gap in the data and every point in the ground has been covered. Just if you see the image on the downside, here there is an overlap, here there is an overlap, here there is an overlap. But if you see this red portion here, there is no overlap. So what happens is that when we go for processing this data, when we see the final output, there will be gap here. Okay, the final output will have a gap here. So that is why it is always important to have equal and sufficient amount of overlap in the images. Forward overlap. This describes the amount of image overlap between adjacent images taken successively along a flight line. And side overlap means this describes the amount of image overlap between images from adjacent flight line. Okay, and all of this is done to make sure there are no gaps in the coverage. Suppose this is our flight line. Okay, our drone is moving along this direction. So first it will capture an image here. And then when it moves a little forward, it captures an image here. And so on. It goes in this forward direction. Okay. So this portion where there is common area, this is known as forward overlap. It goes along the flight track. Okay. And when the drone takes a rotation and comes along, it again captures images here. So this is again captures the image here. This portion is known as side overlap. Okay. That is, this describes the amount of image overlap between images from adjacent flight line. It is the overlap between this flight line and this flight line. And in drone technology, it is always advised to have front and side overlap of more than 75%. This is what it is advised. Okay. So we have completed about the image overlap. This is a very, very important technique because if there is no sufficient overlap, our data will have gaps. Next is designing a flight plan. First is to determine the shape of the project area and flying direction. Second, determine the optimal mounting orientations of the cameras. That is, if you have a study area, if you have to go and fly a drone in an area, first thing that we have to do is to make an AOI, that is a region of interest, area of interest. Okay, if this is an AOI, because we are going to survey inside this box. So it is always advised to make an AOI first. And we should always have an efficient flight plan because it should minimize the number of turns that UAV or the drones make between flight lines in order to save battery life or fuel. Okay, that is, suppose if you are designing, let me make another diagram. If this is our AOI, it's like a rectangular shape. And if we start flying the drones in this manner, suppose we are flying the drones in horizontal pattern, what happens is that when the drone starts from here and moves till here, it has to make a turn here and then it goes to the next flight path. Again, it has to make a turn here and enters the next flight path. And if you count, there will be n number of turns that a UAV has to take. But the problem is that whenever the drones take a turn, it will affect the battery and or fuel. of the drones. So it is always advised to have parallel flying along the longest side of the AOI. But if you make a flight plan like this, vertical or parallel to the longest side of the AOI, we can see that the number of turns, suppose our drone is starting here, it will reach here, it will make a turn, then it will fly through this path, it will make a turn, then it will exit. But if you count the number of turns that it moves along the longitudinal path, it is very less. The number of turns have been minimized drastically. So always the best way to achieve this to always fly the drones parallel to the longest dimension of the project to have a successful flying of the drone and an efficient flying. Okay, next is to compute the number of flight lines. Then we have to compute the number of images, which I will explain in the next coming slides. Then we have to compute the flying altitude, the altitude at which the flight has to or the drone has to fly. This can be determined using the scale of the image. Then we can determine the appropriate flying speed. Okay, it is very much essential to control the speed of the drone, because if the speed of the drone is more, there will be lack of, if we fly the drone too fast, it reduces the forward overlap. And if we fly too slow, it results in too much of overlap, which will affect the overall quality of the final end data products. Okay. Therefore, we should always maintain an optimum speed while we fly the drones. Then comes compute the optimal trigger speed. Then we should select the waypoints. Here the waypoints is not so much necessary for multi-rotors, but this is essential for when we are flying a fixed wing drones or AUS. Waypoints are a set of abstract GCPs that we plan across the airway. Okay, waypoints can be used. It can be defined as a set of coordinates to locate the beginning and endpoints of each flight plan. That is why we are using waypoints, especially for fixed wing aircrafts. Next, coming to computing the number of flight lines. First, compute the coverage of the ground of one image. That is, we can compute the width and height a single image will AB. That is the distance between adjacent flight lines has to be computed. How can we compute that? There is a formula. There's a formula that is being given. That is image coverage into width into 100 minus desired amount of side overlap divided by 100. And then this we can compute the number of flight lines, that is NFL, needed to cover the entire study area. It is then calculated, this NFL, that is the number of flight lines equal to project into the width divided by the AB plus 1. Another important, the takeaway from this slide is that always round up the number of flight lines to the nearest integer to make sure you cover the entire AOI. Suppose when you do the calculation and you are getting a number of 3.2, suppose, you should always round it to 4, because or else there might come, you might not cover your entire AOI. So it is always advised to take 1 extra. Okay. Next, come to the computing the number of images that is required to cover the entire AOI. First, compute the coverage of the ground of one image. Then we have to compute, this is known as air base. The center between this focal length and this plane is known as the air base. This distance is called as air base. And how can we calculate into 100 minus amount of side overlap divided by 100? And this gives us the number of images per flight plan is computed using this formula here. And it is always advised to add 2 images at the beginning of the flight line before entering the project area and 2 images after exiting the project area. Okay, it is because to make sure the entire area is covered, and we can also add trigger images that before we start the drone, we will just take 2-3 extra images to make sure our sensor has been calibrated. Okay, so this is the computing the number of images. Next comes working for stitching drone captured images. Now we talked about how to design a flight plan, how many images have is required, and what is the efficient way to plan or design a flight plan. Okay. Now comes the entire procedure step by step to get the final output result. In that, first we capture overlapping images with a drone and we collect GCPs. GCP is known as ground control point. It is the first step. The first step is basically image acquisition process. Okay. That is, drone captures a series of overlapping images. Here it is said that in the literature it is said that 40 to 90% overlap is advisable or it is desirable. But to have a data with error-free data, it is always advised to have 75 to 90% overlap whenever you fly a drone. Next comes the identification of tie points. Why do we need this overlapping images? That is basically we are going to process this entire drone images, especially photogrammetric drones, using a method called structure from motion. You can read more about it because it's a very vast topic. I will just name the method which we are using, that is known as structure from motion. Okay. What it does is that it will identify the similar features that is present in each of the drone images, and then we match those features. This we don't have to do. The software is built with such capabilities when we process the images. Okay. So identification of key points is very, very essential for the process called structure from motion. Then comes the alignment of process. That is, when drone captures, you can see the blue points here. When drone captures images as every point, each point or each image which is captured, its location, all the measurements have been taken then and there. And when we process the data, we upload the geotag files where all the GPS, all the GNSS data that has been there when the time of acquisition of the images are present there in the alignment process. Then we can incorporate survey GCPs. And if you are surveying a very small area, suppose 0.5 square kilometers, it is using of GCP is not mandatory. But if you want to get a more spatially correct data, it is always advised to use ground control points. Okay, then you will go for the process of re-optimizing. That is, you are making spatially more accurate the image by tagging those GCPs. Then comes the then comes generating the final outputs of the drone images. Okay, and this drone image processing can be done using various commercial software such as Agisoft or Pix4D. In this identification of tie points, okay, they match the common features and which is present in the overlapping images. And from this, they estimate the camera positions and orientations also. And after each, they locate the camera positions and orientations of each image. We can produce a sparse point cloud data. Okay, the first product that we get from the drone image processing is the point cloud data. And what is point cloud data? Point cloud data, that they are millions of points that can be represented in the 3D plane, which gives us both latitude, longitude, and elevation. Okay, so first, when we match these images, we get point cloud data. Okay, it gives a rough representation of the entire scene. Suppose we are surveying this area, this first step gives us a rough estimation of the scene, but each point cloud data has the latitude, longitude, and elevation data. Okay, so what happens is that after we generate this sparse point cloud data, in the next step, we generate the dense point cloud data. Okay, the software densifies it by creating millions of points. This comes the second step. So after we have the dense point cloud data, we generate digital surface model from the dense point cloud data. The software basically interpolates the elevation values of each point cloud data to create a digital surface model. And the final output that we receive from drone image processing is the orthomosaic data. Okay. So I hope this is not so much confusing. I think it might be a little bit in the starting, but this can give you an overall idea. And if you want, you can go and read further on the literatures and the books available. This is the visualization of the drone data products. First, as I said, is the point cloud data. See, these are LiDAR point cloud data. That is why it is in green, yellow, and red colors, okay? But if you use photogrammetric drones, you will get colored point cloud data. See, even this is a pole here, and these are the electric wires. The LiDAR point cloud data, the point cloud data will depict the entire scenes in a series and millions of points. Okay, and these points are being used for interpolation to generate the digital surface models. Okay, what is digital surface model? Digital surface model, it is the representation of both ground and non-ground points. Okay, it will also include the vegetation. It will also include the buildings, poles, whatever is present in the earth feature, everything will be there. This is the digital surface model. But for research purposes or carrying out any commercial activities, we basically need the digital terrain model. And what is digital terrain model? It is the bare earth surface features of the earth. That is how the terrain of the earth looks when we remove the buildings or vegetation from the earth surface. So it is known as the bare earth model of earth. That is known as digital terrain model. This is the different digital elevation models. First is the digital surface model. There are a lot of buildings here, and this rectangle might be a truck or something. And you can see here a trapezoid kind of thing. It is the fence. So when you generate a digital terrain model from the surface model, you will get a bare earth surface where all the vegetations and the man-made features has been removed. And this has been removed using the point cloud data. There is a process called filtration, where we use various softwares. One of the commercially used software is known as Patik software, where we use to manually filter the point cloud data and we generate the digital terrain models. Okay. And accuracy of point cloud data or accuracy of digital terrain models are very, very necessary to have a accurate output or to derive a proper DEM with high accuracy. And another thing with the point cloud data is that because it contains millions of data, point cloud data, the file size of this point cloud data will be in GBs. Suppose you have a point cloud, if you're doing a survey for a 1 square kilometer, suppose, the file size of the point cloud data that we get might be more than 1 GB. So we need high-end softwares to process point cloud data. Next comes orthomosaic images. Okay, orthomosaic images is that when the drone flies, it captures the images at different points. The output after the point cloud data comes the digital surface model. The final output is the orthomosaic data. Suppose we are having multiple images like this. At different locations, the drone is being capturing images. The final orthomosaic photo will be a single image, which will be like an image which is stitched seamlessly. That is, you can't see the variations here of different images. It will come as a single output altogether. And these orthomosaics are orthorectified images. That is that you can make measurements as you can take measurements in the map. Now, these are the few commercially available drone processing softwares. First is the Pix4D, then comes Aegisoft Metashape, then there is Bentley Context Capture, then comes Simactive Correlator 3D, and another one is Drone Deploy. There are also other few open source softwares, but as much as I have seen, the accuracy of the data varies a lot. So it is all, especially when you do for projects or research work, or if you are working in an industry, you should always use a licensed softwares, because the data is also too huge to use it in any crack softwares. So always go for the licensed versions of these softwares, but these are a bit expensive also. Next comes free and open source drone image processing softwares. These are the softwares. Open Drone Map is one software. There is Cloud Compare and QGIS. Have started integrating various plugins where you can modify the point cloud data, you can generate them, and you can carry out filtrations also. Cloud Compare is also another open source software which you can explore, where you can do the filtration process, you can generate digital surface models and digital terrain models, etc. So these are the few open and free drone image processing softwares. And another software, commercially available software that is used to generate digital surface models, is known as Global Mapper. That is also very, very handy, and it is very user friendly also. Next comes to the application of UAVs for disaster management. Okay. See, why are we using drones specifically for disaster management purposes? The first reason is due to the spatial and temporal resolution. Whenever we do research, we have to always have a high spatial resolution data, and it depends on the type of studies. And whichever satellite, especially the Indian satellites or the other satellites which are available across the globe, the minimum spatial resolution that is freely available is 5.4. And if you want to have a satellite data of less than 1 meter or maybe 30 centimeter, you will never be able to access it unless you pay for it. And also, if you pay for the data, you have to wait for a few days until you receive the data. So it is not advised to, it is okay to use those data, but if you want to do real-time monitoring of a disaster, you should always have a rapid and effective measures to acquire a satellite image or a data. So for that, the best option is to use the drone images. And another thing is that temporal resolution. As I had said yesterday, if I want to do a landslide studies of an area, always we do a time series analysis for prediction of a disaster, or to propose some mitigation strategies. In such cases, what happens is that suppose I will have the data of the past scenarios, but I want to see the future conditions of the area. I want to monitor an area. So for that, what happens is that I have to wait until the satellite passes through that same region and then sends the data to us. Okay. So it can delay the overall process. So the advantage of using drones is that about the temporal resolution. Yesterday also we had discussed about this, about the data mining capability of drone, because we can fly the drone as and when we require. Next comes the real-time monitoring of the data. If suppose there is a flood that is happening right now, okay, you want to acquire the data so that you can know where are the people stranded, or which are the areas that in serious, which has been seriously affected. You want to monitor or map those areas, or you want to, inform the police or help the government agencies. For the real-time monitoring, we cannot rely on the satellites. For that, the best way is to use the drone for monitoring purposes. Then no cloud cover. That is always drones is flying at a height of maybe almost about 120 meters. So it is not severely affected by the clouds. Then we can access to the inaccessible areas. If suppose there is a forest fire that is happening, we cannot visually go there and see the amount of extent of fire that is happening, or we cannot see or predict the direction of the flow of fire. Okay, so we can just simply fly a drone above the region and then we can capture the data. Same goes for if there is a glacial late outburst flood, or if there is a mountainous area where there is rain that has been happening continuously throughout the days, And if there is a warning for a glacial lake outburst flood, we cannot directly go there in person and assess the area there because it is a risk to the person there. So we can fly the areas and we can detect and monitor the what is the current level of the water in that area, and if you have to evacuate or you have to change the settlements from there, you can propose that using the drone images. Then comes the emergency services. Especially what happens is that during a time of disaster, we will have to, there might be people that are stranded in locations and people cannot go there physically to help them. So we can even provide first aids. That is, we can provide the disaster aid and rescue also. Then the easy availability of data. If you have a drone or if you have an UAS system and if you have the software, you can just go fly the drones there and then you can come and process it and you can get the data within few hours. Okay. And it is, and about the speed and agility. Why do we say that drones are agile? If you ask, it is because it can move quickly, it can move precisely, and also it can move in multiple directions, how we require it to move. And we can give quick responses and commands as in how we need it. But if it is, we all know that satellite moves in a well-defined path. It cannot move or we cannot tilt the camera according to our wish. So for that, drones are also very much agile. And then we can use all these. All these are the main applications or advantages of using drones for disaster management. And in disaster management, the most essential thing is the timing. Okay, we have to make quick measures or mitigation measures to take control of the situation there. We cannot wait till the satellite passes and it will delay and it will put more people in danger. And another benefit of this drone images is that the data that we acquire, as I said, is high spatial and it has high temporal frequencies. And it is very rapid, it is very effective in managing. Next comes UAVs and disaster management. It can be categorized into three basically. First is the pre-disaster, during disaster, and post-disaster. Okay, if you go to classify the use of UAVs in disaster management, first comes the pre-disaster. Okay, that is, we are taking proper prevention measures, and we can detect the hazard before it occurs. Okay, so that is the effect of using drones in pre-disaster as a measure. Then we can come during disaster. We can use it for monitoring purposes. As I said, that if a fire is extending over an area, we can monitor it like that. If there is a flood, we can fly and see the scenario of how much area has been inundated. Then we can use it for rescue operations, and also we can deliver essential basic necessities. Okay, and that is, we can use heavy drones for that purpose. Then comes the post disaster. Okay, we can use this drones for basically assessing the damage, or we can use it for the recovery purposes. And during disaster, it is very difficult, as I said, to rely on satellite data because there won't be, if there is no satellite pass to monitor, and if we have to take emergency measurements of the exact time and as when and required, the only way to rely is on UAVs. And the resolution of the satellite data is also an limitations. And mostly if you see during a heavy rainfall, or if there's a flood, or if there is a disaster that is happening, if there is earthquake, mostly the telecommunications of that area will be also affected during that disaster time. So the best way to do the communication is to rely upon the drones. And the drones can also be used to locate the victims and the affected animals during the case of forest fire. And then we can also use thermal camera. Suppose there is an earthquake. Earthquake is such kind of a geophysical disaster that there is no early warning systems. And the only available early warning system for earthquake is prior 7 seconds. Nothing can be done within the 7 seconds. So if somebody is trapped or some things are trapped under rubble, we can detect it through thermal sensors, and that can be deployed using the drones. So these are the application of UAVs in disaster management. I will just read it out once again because I've explained it once before. So in the pre-disaster studies, why do we use it? We have high resolution orthomosaics, DSM and DTM. We can model the future scenarios of hazards using these data sets. We can analyze and interpret potential triggering factors for each disaster event. Suppose in the case of landslide studies, landslide is the phenomena, but there are a lot of triggering factors that play behind the scene. So those high resolution data can be also acquired using the drone data. Then preparation of high risk zone maps. Okay, and we can make susceptibility maps, and then we can inform the government because the accuracy of these data maps will be also high. Then we can create high resolution terrain maps and derivatives to study the terrain and structural characteristics of the area. Then the multi-temporal observation over a same area, that if you have to, if there is a landslide that is happening in Wayanad or in Himalayas, we can go and have repeated monitoring using the drones. Okay, the saturation points, everything can be analyzed. Then comes during or post disaster studies, we can collect data and we can incorporate into the models. And there is 3D visualizations of affected area. As I said, that the point cloud data that we get is a 3D data, and then we can generate the DTM and we can visualize the entire region in the 3D models. And the high resolution imagery of centimeter level spatial resolution can be acquired over the affected area to assess the damages. Then we can gain critical informations on the infrastructure, logistics, transport system. We can even determine the evacuation zones, and we can determine, during a disaster, if somebody is trapped somewhere, if there is a flood, maybe somebody is trapped in the rooftop. We cannot go and see them, but we can fly the drone, we can monitor, we can send the data to the governments or the militaries. Okay. So yeah, that is what is in the slide about the application of UAVs in disaster studies. And in the landslide studies, how we are now, I'm going disaster specific. That first one is the landslide studies. First is the monitoring the failure surface, and we can also keep monitoring the slow moving landslides, which is known as creep. Then we can measure the geotechnical parameters. I will explain about the landslides in detail in the coming slides. Next is the earthquake studies. As I said, that earthquake happens very sudden, and there are no early warning systems, and the early warning systems that we have is just for 7 seconds, and nothing can be done. No evacuation can be even done in that time. So during this, if disaster, if somebody is trapped under the rubbles, we can use thermal sensors to detect, and then we can use drones, especially heavy drones, for delivering first aids to the affected people. Then drones can be used for geomorphic studies. That is, during the case of floods and landslides or avalanche, you can use drones to study the structural features of that area. That is the geomorphic features of that area. And then high resolution DTMs can be used, and the orthomosaic images can be used for studying the change detection. We can change, if a river has been inundating, or you can see that the change of course in the river can be detected and monitored using high resolution drone products. Then floodplains, riverbeds, erosion, sedimentation can also be studied. Basically, through the geomorphic studies, we can incorporate these outputs into the modeling, hydrological modeling also. Urban flooding, we can use high resolution orthomosaic, detect the inundated areas. In the flood studies, we can delineate the potential flood risk zones. And then we can use the high resolution digital terrain models into hydrological models. And then also we can go for the damage assessment. You can go for change detection, how an area has been changed post flood. Then we can study about the forest fire studies. We can monitor the vegetation health. We can generate a risk map. And then we can also have a 3D visualization of the terrain features of that area. And in flood studies also, I would like to add a point, that is, we can study about the amount of changes in the river dynamics that has been happening. We can detect the change in the course of the river and also the sedimentation processes. Next, coming to the landslide studies. So to map the degree and extent of landslide affected in the areas, we can use drones. To monitor and study the geomorphic features, also we can visualize the high resolution orthomosaic data even in the 3D. So now the studies for landslide, it has been so advanced that there are a lot of softwares, there are a lot of numerical models, which suppose you are studying the rock falls of an area. There are a lot of softwares where we can incorporate point cloud data, or you can capture the shape of a rock, and then or you can capture the shape of the terrain that using the point cloud data. You can generate the DSM, and then you can incorporate into various numerical models to predict the future landslide scenario. That is, if at all a landslide occur in a place, what will be the direction of movement of the materials? Okay, then we can integrate high resolution terrain generated by drones and LiDAR sensors and numerical models. Then we can attain high resolution DTM for studying the structural features. So one of the main contributing or the triggering factors of landslide is the lineaments or the geomorphic features such as faults and lineaments. These features can be detailedly mapped using the digital surface models. Okay, when you map or if you take a satellite data, the DEM has a resolution of maximum 30 meter, or you can get allows pulsar of 12.5 meter. Okay, so these maps, which like these satellite DEMs, which are freely accessible, has a higher resolution, and it cannot give us a accurate because the landslide which happened, it is a site specific natural hazards, right? So if you have to get a detailed and in-depth knowledge, it is always better to go for high resolution data, especially when we are going to model the landslide scenarios. Then comes the rock and boulder structure shape estimation using point cloud data. There, see, when the rock fall happens, okay, there'll be different type of lithologies of an area. Some might be phyllites, some might be quartz. So you can go to an area, you can model the shape of the rock, because when the shape of the boulders also changes, the way it rolls down the slope will also change. So it has been so advanced that the technologies that you can use LiDAR data to monitor or detect the shape of the rock, and you can incorporate into various numerical models. And also there are various geotechnical software, especially in the mining industry, where we detect, okay, maybe it might be a terrestrial laser scanner where we will scan the benches of open cast mines, which is a point cloud data. We will generate a DTM from them, and then we will simulate slope stability analysis there to see if a landslide or if there is a slope there which is susceptible to failure. And then we can see the direction of motion, in which direction will the, if a failure happens, will the sediments move along. Okay, and we can also use for accurate volumetric estimation pre and post event. So suppose there is an area that is prone to landslides, you can go and take a high resolution DTM before the post pre-event, and then after the studies also, after the event has occurred, you can again go and survey. And if you do the differencing of both the DTMs, you can estimate the amount of volume that has been come out of those areas. Okay, and also you can generate a very detailed high resolution landslide susceptibility and hazard maps. Now we are coming to the basics of LiDAR remote sensing. So LiDAR, it is basically an acronym. It stands for light detection and ranging. And it is also known as laser remote sensing because it uses laser to detect or given the energy to detect the areas there. It is a type of active remote sensing. Why is it an active remote sensing? Because it uses laser beam. It is an artificial source of energy to illuminate the target. Okay. LiDARs uses intense pulses of laser lights to measure the arrangement and structure of the atmosphere or the area or the object present in the terrain. Okay. Laser is used to detect and measure objects and its elevations. So before the LiDAR remote sensing came into picture. Before, we used to use laser scanners. And the sole purpose for using laser was that for surveying purposes. Okay, so this LiDAR technology is new. It uses laser-based remote sensing technology. So in this figure, you can see that we have a laser beam. And if you ask, what is laser? Laser is a device that produces a monochromatic coherent beam of light. Okay, what is monochromatic here? Laser is a device that produces a monochromatic coherent beam of light. Monochromatic means it uses a single electromagnetic radiation, and mainly it uses green and NIR radiation, like EM waves, because as we have seen that NIR and green waves have more reflective properties. Okay, so that is why laser uses a single electromagnetic radiation. So that is why it is known as monochromatic beam. And then therefore the device that generate a light wave. Okay, actually laser is a sensor that we use in LiDAR remote sensing. So together this entire technology is known as LiDAR remote sensing. And it generates a light wave using only a very narrow beam. Okay, it is coherent beam of light. Okay, and it is known as active sensor because it carries its own source of energy. It can also happen both, the survey can be done both in day and night, and we can measure the intensity that was sent and that was received back. That is, suppose we have a laser sensor here, we will send the laser pulse to the target and we will measure the time it takes to, that is the time the backscatter energy comes back to the sensor. It is called backscatter because it is an artificial source of light. We are sending it and it is sending back to the sensor. The sensor is sending the light and then we are transmitting back to the sensor. So that is why it is known as backscatter. Okay, so that is why LiDAR was basically used for the surveying purposes. And then the LiDARs drones that we use, it does not give us an imaging output, such as orthomosaic cannot be generated. We use basically point cloud data. And then come to the next one. Come to the working principle of LiDAR. Okay, so here the image here shows a laser transmitter and the laser receiver. The red light here is the laser beams that have been sent to the target. It interacts with the source here and then it gets reflected back and it is received by the sensor here. Okay, LiDAR scanning measures the distance. It measures the distance by illuminating a target with pulses of light just outside the visible spectrum to measure. That is, it is a monochromatic light, and laser basically uses the green and NIR waves. And it reflects off its surface and it returns back to the surface. It is found out by the formula using speed of light and the time taken for the reflected backscatter to reach back to the sensor, and is divided by the 2. Okay, and it is capable of collecting large amount of data in a very short period of time. And another advantage of using LiDAR remote sensing is that the sensor has the capability to move, to rotate the device. The entire device rotates on the base to provide measurements within a 360-degree horizontal arc. That is, you can even go to a monument, or you can go and measure a building or the face of a pen using a scanner which can rotate in 360 degrees. The sensor can rotate in 360 degrees. And the laser data produces will be point cloud data, which has X, Y, and Z information. X represents the latitude, then comes longitude, as well as the elevation information can be acquired. And it creates a 3D model of any object. That is what, if you want to go and scan an object, you can use a laser beam and you can scan the entire and you can model the same into the softwares. Next comes classification of LiDAR systems. The classification of LiDAR system is basically classified based on where the sensor is mounted and how the data has been collected. So first comes the terrestrial laser scanner. The terrestrial laser scanner is basically mounted upon a tripod or it is in a fixed position on the ground. Okay, and it can scan stationary objects. such as building. It can even scan the open face of the mines. It can map the rock outcrops. It can map trees or archaeological sites too. And it can provide very high and accurate data. And it will be also very high resolution. Then comes mobile laser scanner. Mobile laser scanners are basically mounted upon a moving platform. Okay, vehicles, it can be cars. Nowadays, I think most of us have even iPhones. And then if you have an iPhone, you can make measurements of an object. Okay, that basically uses laser technology there. So the systems, this shows how fast the technologies has been developed. And the mobile laser scanners has inbuilt global navigation. It has an internal measurement units which records the exact position, and it has sensors which and GPS systems to record the exact position and orientation of the scanner while the maybe the car or aircraft is moving. Okay, so this is about the mobile laser scanner. Then comes the airborne laser scanner. The airborne laser scanner is basically mounted upon the aircraft or drones or helicopters. And the advantage of airborne laser scanner over terrestrial and mobile scanner is that it can scan large areas and it can emit laser pulses towards the ground while it is flying. So the signal that is returned are also used to generate very high resolution digital surface models, and then you can also generate the digital terrain models, and then it can cover very wide areas. And one of the advantages is that you can even detect the canopy. We can map the canopy of the forest areas. We can do topographic surveys. We can even detect the floodplains, coastal mapping, etc. can be done using the laser scanner. So the LiDAR data characteristics is that the raw data will be in point cloud format. It will be the file format of point cloud data will be in .las or in LAZ format. The .LAZ format will be a compressed version of the LAS format. Okay. So the original version of the point cloud will be .las, and it is a very high spatial resolution data that we will generate using the LiDAR scanners. And another advantage is that the data is having large volumes. It will be more, the point cloud data will be millions of points more than compared to the point cloud data that we generate using the photogrammetric drones. Next comes to data collection with airborne LiDAR sensors. That is, if this is our aircraft and the sensor will transmit the laser scanning signals to the target area, it reflects back and then it is being sensed by the receiving sensor. So it measures the distance to the surface by timing a laser pulse and its corresponding return. That is, we will send a laser beam to the target and we measure the time it takes to reach back to the sensor. Okay, emission of a laser pulse. We use here laser pulse, continuous laser beams to map a target. Then we record the backscatter signal. I said, why do we say it a backscatter, not reflection? Because we are sending the signal from the sensor and then it is interacting with the target and it is reflecting back. It is getting backscattered. So that is why we record the backscattered signal. Then we measure the distance, that is time of flight, and the speed of flight is also measured then, and the time taken for the returning backscatter energy to come to the sensor. And we can do the computation of precise echo position as and when, which point of the flight this laser pulses were sent, and each aircraft has its own internal measurement units that will measure the location, the lat and longitude, and the amount of, and it has a GPS also installed in it to know its exact location. Okay, and the point cloud data that we attain will also have XYZ coordinate information, that is the latitude, longitude, as well as the elevation data information. Now we come to the advantage of using LiDAR systems. Okay, one of the main advantage of using LiDAR sensors is for we can monitor a very thick vegetated area. When we use photogrammetric drones, that is when we use point cloud data of the photogrammetric drones is it does not have the ability to penetrate the canopies and detect the ground areas. But when we go for LiDAR sensors, the advantage is that it has the capability to penetrate through the canopies of the tree and reach the terrain just below the vegetation that is available. And the reliability of data, because the LiDAR data is so dense and it has a higher accuracy than compared to the point cloud data. Because in point cloud data also, when we do the survey, we can miss out few details such as the bias of the electric post or the area that is below trees, etc. So it can be covered up using the LiDAR sensors. And another advantage is that it has both day and night operation capabilities. Because it's an active sensor, we can operate it in night as well as day to do the survey of a terrain. But this is not possible when we use the photogrammetric drones, because especially when we are using RGB sensors. Okay, so when we have RGB sensors, we are limited to flying it in the daytime only. Then comes the high resolution post-processed outputs, such that when we use LiDAR remote sensing, the data that we acquire will be of high resolution and it will be more reliable. Then comes this LiDAR systems has a wide variety of applications. First comes in the geology, then you can use it in geomatics, geomorphological studies, seismological studies, forestry, automobile industry, mining industry, etc. That is, in geology, you can use laser scanners or LiDAR remote sensing, as I said, to detect the terrain, to do survey of a terrain, and you can generate, geomorphological maps. You can study about the terrain of the area for flood, for modeling the flood studies. You can use it for studying the landslides. And then comes to geomatics. That is when we use it solely for the survey purposes. Especially in the mining industries, what we do is that we always deploy LiDAR sensors for accurate estimation of the amount of resources that we have been excavating. Okay, so it basically we use it for volumetric estimation processes as well as to monitor the slopes of the mines. We can use LiDAR sensors to model the slope stability of the areas, and which can be used because these surveys are very, very crucial, because when we go into the commercial industry, the accuracy can never be compromised. Okay, so it is always advised to use high resolution LiDAR sensors to do the mapping and monitoring purposes. Then comes the geomorphological purpose studies, where I've told we can use it for hydrological modeling. We are surveying the terrain of an area, and the data can be incorporated in the hydrological modeling, and we can do study the structural features of the earth can be identified using the LiDAR sensors. Then you can use for earthquake studies. Then you can do for forestry application is that when you can detect the width of the bark of a tree, and you can do, you can separate you can count each tree canopy of a vegetation or a forest area using LiDAR sensors. And nowadays the LiDAR sensors are also being used in automobile industry. That is, when we move across or when we take reverse, we can get a sound. That is basically the sensor system that is there. It basically using the ranging system that is measures the distance. So it is used in the automobile industry. And as I said, the use of lasers, scanners in mining industry, that is to map the bench faces and then to derive the volumetric estimations of the mines. So this is the last slide of the lecture series, that is advantage of LiDAR systems. So yeah, this I will wind up my class here. So thank you so much. Somebody has asked what is AOI? AOI is area of interest. That is the region that we will choose for doing our research or survey. Yesterday, somebody had asked me what is the use of remote sensing or drone technologies in the marine sciences, if I'm not wrong. So I had done quite a bit of research on it. So I would say that you can use satellite data or drone images. You can map the illegal fishing. You can map the health of mangrove forest that is present. And then another application is that what do you mean by the term waypoints? Yeah, okay. I will just tell you 1 minute. So another thing is that you can map the coral reef, health of the coral reef, and you can map the illegal fishing. And yeah, these are the applications of satellite images, and you can count the animals that are present as the whales or seals. So that can also be used. The term waypoints. Waypoints are basically the GCPs that we align across the runway when we use for when we use fixed wing drones. That we keep the starting and ending of each flight line. There any more doubts? Hello, Jishnu. Hello.
Hello, Danu. Can you hear me?
Yeah. Yeah, I can hear you.
Hello.
Hello.
Can
Hello.
you hear me? Can you
Yeah.
hear me?
Yeah.
Okay. Then we finished today's session, right?
Yeah, just 1 minute. There are two more
Yeah.
questions to be addressed.
Okay, no problem.
Yeah.
Go ahead. Okay.
One student have asked what are the plugins that is used in QGIS for drone image processing. Actually, in QGIS, we cannot do the image processing of drones, but you can manipulate the point cloud data. So for that, there is white box tools that are available, as well as LAST tools are also available in QGIS as plugins. And another students have asked about, any hands-on training regarding analysis of drone images. Actually, the problem was that I do not have access in my personal laptop for the licensed softwares. So that is why I couldn't get given hands-on training regarding the image processing of drones. But I would tell you that, okay, wait, okay, yeah, I will tell you that there are a lot of websites or the softwares, as I said, like Agisoft, as well as Pix4D, and there is Bentley Context Capture, and then there is Simactive Correlator 3D softwares that are available, and they are giving student license also, so you can, and 10-day free training also, so you can enroll in that, and as well as there is a detailed manual also, user manual, which will give you everything in detail. So I couldn't use that actually. QGIS, we use white box tools. And another one is, ma'am, in your opinion, will AI replace some of these technologies in future? I don't think AI will help in automating various redundant tasks, but it cannot completely replace these technologies in future. Yeah, Jishnu, I have completed.
Okay. Thank you so much, Danu, for addressing those questions. And I
Yeah,
believe maybe they asked questions from yesterday's as well, and you might go through that one too, right? Okay.
yeah.
Actually, I had some other meeting, so I was there. Okay, sorry for that. And so today also we had around 20 people. And so I'm happy to have each one of you in this 2 day training on the training or the class on the remote sensing as well as the drone technology. I hope you gain a lot of knowledge in this one. And if you have any further queries regarding the same, then you can contact Dhanida, and we can provide her Gmail ID if it is okay for her, and you can communicate with her through the mail. Okay. Do you have any final words to them? Like any Dhanida? Do you have anything to say? Do you
I would
have?
say that, like, there are a lot of, you can explore a lot of open source softwares, and then
Mm-hmm.
there are a lot of websites where you can download point cloud data for LiDAR as well as the photogrammetric point cloud data. So when you have free time, you can, just visualize it and try various analysis on it if you can, so that you will get an experience.
Okay. Okay, then that's great. And if anyone of you want to get a drone license, like you learned about drone and the drone technology and the remote sensing, but if anyone of you are interested to get a license in the rights license for the drone, maybe the Indian aviation license or the European one, please reach out to us. We have some collaborator who is giving certification courses for that, but it is a bit expensive. So if anyone want to get a drone license in the future, please contact us. We will give you the informations to you, and it will be around a 1 month program or 2 weeks program, or sometimes six months program. But it is expensive, as you know. It's very expensive. But if you want to have one license, then we can support you in it. Okay. This is all about the intent, and sorry, not the intent. This is all about our today's sessions. And if you want to give a feedback, then warm welcome. Anyone? So after that, we can finish our session. Anyone want to give a feedback on our class? Anybody? They can just turn off their mic, and you can give the comments. Hello.
Yeah, I think nobody is
Yeah, but
willing to.
maybe
Yeah.
I will ask some of our interns if they are willing to. So yeah. Yes. Melvin, then Febin, Melvin, and my senior is also here, Naveen. Yeah, Melvin. Okay,
Yes, sir.
yeah, okay, Melvin. Can you just give me feedback on the session?
Yes, sir. This session was a very wonderful session. Technology is probably my weakest, like, knowledge barrier. But even with that difficulty, I think this session was easy to grasp. And I think the PPT was very well done. I think the PPT making was one of the best portion. Was lot of the things that was said throughout the class within these 2 days. I think lot of it we could grasp through the PPT itself, and with the Mrs. help and her thorough explanation, it was quite wonderful.
Okay. Thank you, Melvin,
Thank
for
you.
that. And
Thank you so much.
yeah. So actually, my senior is also here. If you don't mind, then maybe he can. Mr. Naveen Lal. Naveen, hello. Can you? Hello. You're not audible to us. Yes. Now you are. Now you are. But voice is very less. We cannot hear you properly. I cannot actually. So can you speak a bit louder?
Is it audible?
Yes, yes. Now you are.
Yeah, actually, it was a very nice lecture. Actually, we could explore the areas of drone technology and how it can be used in our subject area. It was a nice lecture.
Okay. Okay. Thank you so much for your comment, and maybe Some of it you can keep a wind up or okay. So we have Ruxana. Ruxana. Ruxana, are you there? Hello. Hello, Ruxana. Okay, that's fine. Then maybe.
Hello?
Yes, Ruxana.
Uh,
Can you just
uh,
give
yes,
your
sir.
opinion about the
Actually,
session?
yes,
Yeah.
yes, sure, sir. Firstly, I would like to thank ma'am for giving us a wonderful session. I'm totally new to uh, this topic, and but even though I'm new to this, I could grasp the things well because she explained it in a uh, very structured and simple way that even someone like me from a biology background could understand it properly. So thank you so much, ma'am, for doing this.
You're most welcome.
Thank you, ma'am.
Okay. Okay, then thank you, and we will pick two more. Maybe Arunabha Das. Arunabha, right? Arunabha.
Yes, thank you
Yeah.
for this beautiful session, ma'am. And it is new to me. Wonderful session. Thank you.
Okay.
Welcome.
Thank you. And Delphia PV, right? Delphia. Maybe after Saikat we can finish. Delphia. Delphia PV. Are you there? Okay, then Saikat. Mr. Saikat Kumar Maji.
Hello.
Yes.
Yes.
Actually, I can't hear you properly. Hello. Saikat, I think you have some network issue, so we cannot hear you. So anyway, we will finish our session. It is going to be around 1.5 hours or 2 hours. So we will wind up our session.
Hello.
And hello, then.
Yeah, actually, I would like to thank you for giving me this opportunity and taking up
Okay,
this
no.
initiative, yeah, to conduct classes and spread awareness and to make people know about such kind of technologies that exist and taking up classes and taking effort to make it happen. And all the best for you.
Okay, thank you so much, then. And actually, I would like to express my sincere gratitude to you for accepting our invitations and coming and giving a lecture on this particular topic, especially drone. And very rare number of people are working on the drone, and maybe the rare number of people who works and do the lecture is very rare. Okay, thank you so much. And anyway, we will look forward to future collaborations and your lectures. Okay, thank you so
Okay,
much,
thank
Danu.
you. Yeah,
Thank you
thank
so
you.
much. Thank you, everyone.
Bye.
Thank you, everyone, for joining. And we will come up with some other good sessions. Hopefully, you might enjoy as well as it will be useful for you in the future. Thank you. And your certificate will be issued in 1 week. Okay. Thank you.
Thank you.